and phase velocity work, I've got some examples here of different group and phase velocities, so you can see how the pulse moves under these different conditions and what the ripples, the phase velocity underneath the envelopes is actually doing. So in this first example, the group and phase velocity are positive and equal. This is easily the most boring example because it's just some shape moving in the positive direction. The ripples are moving the same speed as the envelope around the ripples, and that's what you get. So this is the case of zero dispersion. There's just a linear relationship between omega and k. In this next example, we have a group velocity that's positive, but a phase velocity that is zero. So you can see an envelope moving in the positive direction, but the ripples underneath are actually stationary. So the derivative d omega dk here is positive, but the ratio omega on k is 0. In this example, we have a group velocity of 0, but a phase velocity that's positive. So in this case, d omega dk, the group velocity, is 0, but the ratio of omega and k is positive. In the next example, we have group and phase velocity both positive, but the group velocity is larger, so the derivative d omega dk is larger than the ratio of omega and k. So you can see the envelope moving faster than the ripples. The ripples are being left behind. In this next example, we switch those roles, so now the phase velocity is quicker, and so you can see the ripples sort of catching up, going through the envelope and moving faster. And so in this case, the derivative d omega dk is less than the ratio of omega and k. Now we have some slightly more exotic examples. We have the phase velocity positive and the group velocity negative. So the ratio of omega and k is positive, but the derivative d omega dk is negative, and that would look like this, where the phase velocity is moving in the positive direction, group velocity in the negative direction. We can see the ripples moving forwards and the envelope moving backwards. And lastly, we can look at a positive group velocity and negative phase velocity, and that behaves like this. We see the envelope moving forward, but the ripples underneath moving backwards.